Good day, everyone. This is Sir Paul Joral R. Santos, and I'm going to discuss random variable. In some experiments, such as tossing a coin 3 times, rolling a die twice, rolling or drawing 2 balls from an urn, and the like, few are not oftentimes concerned with every detail of the outcomes. We are usually interested in some numerals associated with the outcomes. For instance, if a coin is tossed twice, the set of all possible outcomes S of the experiment is S contains the outcome or the first outcome, which is two tails, the second outcome, which contain tail and head. The first one is tail and the second one is head. The third one is the first one is head while the second one is tail, and the last one it is two heads. Now, if you're interested in the number of tails that came out in the experiment, then we can assign numbers 0, 1, and 2 for each of the four possible outcomes. Thus, we can write, as you can see on the table, the sample space that contains the four possible outcomes, and on the right side of the table, the number of tails just tells us the number of tails on each outcome. So each outcome corresponds to a certain value, which is the number of tails. For the first outcome, there are two tails, so we have 2. Second outcome, we have 1. Third outcome, we have 1. And for the fourth outcome, so since it does not contain a tail, so it is, or the value is 0. Now, from the table on the left rather, instead of writing of tails, we can denote it as x. We can replace the number of tails by x. We can replace the number of tails by x. In symbol, we can also rewrite it as x equals 0, 1, 2, or the set that contains 0, 1, and 2. In this case, x is called a random variable, and 0, 1, and 2 are the values of the random variable. To formally define a random variable is a set whose elements are the numbers assigned to the outcomes of an experiment. It is usually denoted by uppercase letters such as x, whose elements are denoted by lowercase letters. In this case, we can also write it as x sub 1, x sub 2, x sub 3, and so on. There are two types of random variable. So in this slide, we can see the first type of random variable, and it is what we call discrete random variable. So what is discrete random variable? To cut these long paragraph, it is simply the random variable that arise from counting, or if the values can be represented by whole numbers. For the second type of a random variable, it is what we call the continuous random variable. And these random variable cannot be represented by whole numbers. Usually, it is infinite. To make it clearer, a random variable x is said to be discrete random variable if it has a finite number of elements. Or it can also be infinite, but it must be represented by whole numbers. To easily distinguish if it is random variable or if it is discrete or not, These values usually arise from counts, or if we can count the number of values in a certain random variable, then it is discrete. For continuous random variable, a random variable y is said to be continuous if it has infinite numbers of elements, or infinite but cannot be represented by whole numbers. To make it clearer, these values usually arise from measurements. If we are to measure some values, then it is a continuous random variable. The first example, a teacher's record does the following. First, the scores in a 50-item test. Second is gender, and the third is height of the students. And each of these are represented by capital letters, or by capital letters X, Y, and Z. So for X, we have the scores. For Y, the gender, and for Z, for the height. And we are going to classify each variable above as discrete or continuous. For the answers, X is discrete because the scores can be represented by whole numbers from 0 to 50. For Y, it is discrete also because we have countable number of gender. And for the third one, Z is continuous because the height arise from measurement. So for your practice exercise, you're going to distinguish if it is discrete or continuous. So that is all for this video presentation.